A common question we get is, how big is that battery? To answer that question, we first have to look at how much energy is stored in the battery. Now, the energy is equal to 8 megawatts times 2 minutes. So if we work that out, that would be 16 megawatt minutes, which is kind of an odd thing to say. We want to convert it to megawatt hours or kilowatt hours if we can. And that's very easy to do. With dimensional analysis, we'll just say there are 60 minutes to the hour. And when we do that, we determine that there are 270 kilowatt hours of energy in the battery. Now that we know the total amount of energy we need to store, we need to figure out how we can make this large battery using smaller individual batteries. Now, for better or worse, we chose to use sealed lead-acid batteries. The batteries are just a little bit bigger than a common car battery. Looks something like this. It's got 2 terminals on top. There's the positive one, so don't forget that. Now, the battery is 12 inches this way, 8 inches deep, and 9 inches high. From the datasheet, we found out that each battery can provide 1 kilowatt hour of energy. So if you just look at these two, you can say, oh, you need 270 batteries. Actually, we derated the batteries a little bit because a lead-acid battery will last longer if you don't discharge it as deep. So we assumed that each battery would only provide 1/2 of a kilowatt hour. So in our final design, we chose to use 540 individual batteries. Next, we needed a place to house the batteries. The most convenient thing we could find was the ISO shipping container. And perhaps you've seen these. They're about 40 feet in this dimension, and if we look at the side view, there's enough room for a person to easily stand. Now, with these small batteries, we decided to put 3 shelves, like so, to hold the batteries, and 3 on the other side. And we also decided not to use the entire box. We decided only to use half of it, which gives us a little extra room to store the batteries and put some environmental controls inside the box. The last calculation is to figure out how many boxes we need. So 540 batteries, and 8 inches per battery. There are 12 inches per foot. And finally, each box has not 20, but 20 times 6 feet of shelf space. Remember, we put 6 shelves right here. Okay? And when you do that, it turns out you need 1.5 boxes. Our final design looks like this. We've got the yard itself, which is outlined here. We've got 4 shipping containers. Each shipping container has 135 batteries in it. And finally, we installed our power converter here. And as you recall, that device was the thing that converted the direct current from the battery, which is symbolized like so, to 3-phase alternating current. And here are the connections to the various battery boxes. And that's it. That's what our battery yard looks like.